Okay, so we've got number 10 here on the review. Find the coordinates of P that would make PIG a right triangle where G is the right angle. All right, so I is 2, -3. That's I, right? G is -3, 1. Okay, that's weird because these 2 points would be nice, but that's not going to make G the right angle. Okay, that would make it a right triangle, but not with G at the right angle. So, tricky problem. Very good one. Like it. All right, so what we're going to have to do with coordinate geometry, we have to justify, so to prove a right angle, think we need perpendicular segments, right? So we need slopes. So our tools of geometry, tools of coordinate geometry specifically, are slopes, distance, or midpoint. This is a slope problem. So slopes must be negative reciprocals. All right. So we're going to calculate the slope that we have. Um, that's GI. So the slope of GI is -4/5. The rise is 4, the run is 5, and as we move left to right, it's heading down. So that's what we got to make sure we know. Now a perpendicular segment to form our right angle, okay, we're going to need the slope to be positive 5/4. Whoops, I didn't write 4. Positive 5/4. So what we could do is from G, either count either up 5, right 4, or down 5, left 4. Whatever, whatever you want to do. So there's a few locations that'll work. I'm just going to go, there's enough room for me to go up 5, right 4. This could be one of the locations that we could find, what is it, P. There's several, all right? Basically anywhere along this line will work. All right, I'll pick one. I'll pick P is at 1, 1, 2, 3, 4, 5, 6. So I got P. One of the locations is 1, 6. All right. We could do the whole equation of it, but I don't want to do that. Let's just pick P as 1, 6. Now, let's justify why is it going to force us to have a right triangle. Okay. Um, Sorry about this. With P at 1, 6, PG has a slope of 5/4, and GI has a slope of -4/5. These slopes are negative reciprocals. So angle G is actually I should say this. I should say it the right way. So PG is perpendicular to GI. This makes angle a right angle. Because perpendicular segments form right angles. Triangle PIG is now a right triangle because it has a right angle. Okay, so we'll move on to the next one. So isosceles triangle. All right. So -2, 4 That's D. 0, 1 is O. And it doesn't say which sides are going to have to be congruent for this. All right, so why don't we just do this? This would make it really easy for us to put G right here. Okay, and why is that going to make it a right triangle? Well, we're going to end up getting the same length. Okay, if I go over 2 up 3, we're going to get the same length. But I got to justify that. So let's use G at the location 1, 2, 1, 2, 3, 4. Okay, double check that. 2, yes. G at 2, 4. Let's see. So the lengths, this one for isosceles, think you want the lengths of the sides. Okay. So D2O. We're going to calculate that. It's going to be 13. 9 plus 4 is 13. Okay. So DO has a length that's the square root of 13. Now this is not the most efficient thing in the world, but we're going to do it again. Now we know it's the same length, but to talk through it and say, oh, you know, you're counting the same distance over and up, that's just risking somebody taking off for that. Let's just go through the process again. We showed it here, so we get to use it, right? Just take no risks for anyone to take points off. So they both have a length that's square root of 13. All right, so here goes. My claim is that now DO is congruent to GO, and that's because their lengths are equal. That gives us triangle. DOG is isosceles now because it has two sides that are congruent. So that's our justify. It's kind of a proof, but again, I don't want to take any risk, so I make sure that I get everything done that I'm supposed to. All right, let's see if we got time for one more on this. Okay, prove that it's scalene and it's not right. Okay, there's a lot going on here, so let's go ahead and graph this. Make up your own axis. Whoops, that's Y. Okay, and then we'll throw X here. Negative 3, 0 is A, B, and C. Now we know, we can see that it's isosceles, or that it's scalene. We can see that it's obtuse, but let's not take any chances there. How do we prove scalene? Well, we need the length of every side. So that is going to guarantee us something to talk about. You're going to have no two sides of the same length, so none of them are congruent. You just don't want to take any risks. So AB got 6 up and down. Now be careful here. We're doing the length. So that's an A squared plus B squared equals C squared problem, not a slope problem. So AB, the length, is 6 squared plus 7 squared equals D squared. 49 and 36 is 85. Okay, so square root of 85 is the length of AB. Okay, BC's nice. You don't have to say much there. It's just 4. The reason we don't have to show anything is because it's straight up and down, and you showed it right there. All right. Now for AC, 1, 2, 3, 4, 5, 6, 7. It's 7 across, 2 up and down. So 7 squared plus 2 squared equals, I use D. It's probably not the greatest thing to do, but I don't think anybody's going to take off for that. So square root both sides, and AC is now the square root of 53. What we can say now, just from the lengths, is that all sides are different lengths on triangle ABC. So triangle ABC is scaling. That was our first job. Now there's a way to show from here that it's not, that it's not a right triangle. So we can take the side lengths, which we have, okay? Let's put them on here. This is square root of 85, this is square root of 53, and that's 4. And we can show the Pythagorean theorem doesn't work, okay? That's one way. The other way is just to get the slopes of all the sides and show that none of them are the negative reciprocals. Since that's more in line with what we're going to, working on right now, I'll probably do the slopes of every side too. So the slopes. Let's do that. Okay, so first AB, it is rise is 6, run is 7, and it's moving up, so it's positive. A C, we have a 2/7, right? It's moving up, so it's positive. And for BC, it's a 4/0. Rise is 4, run is 0. That's undefined. Okay, so none of these slopes are negative reciprocals. So no sides are perpendicular. Therefore, no angle in triangle ABC is a right angle. All right, that's good enough for that one, and that'll finish up this session.